everyone. In this session, we will be starting another classical problem of process synchronization, that is called reader-writer problem. And it is an important problem, my dear friends, from the gate point of view. So we will first see what are the problems, what problems can be arise if reader and writers both access the same database. We will see the problem first, okay? Then we will also see the solution for these problems with the help of binary semaphore. Means how we can synchronize reader and writer, okay, to avoid these what problems which are arising due to unsynchronization, okay, due to unsynchronization between the what reader and writer, my dear friends, between reader and writer. We will see the solution with the binary semaphore with the help of codes. We have different codes for the reader and writer. When reader want to access the database, then it will execute their reader code, and when writer want to access the database, okay, same database, then what writer will execute their own code. Okay, I hope you understand clearly. So first I am going to give you all the points. What are the problems? What problems can be arise if both reader and writers, okay, here you can consider about reader and writers just like as a process. If both the process reader and writers want to access the same database at the same time, then what problems may arises here? Okay, what problems may arises here? Okay, so please note it down. Reader writer problem, okay, reader writer problem. And we will see in the same video the solution of reader writer problem with semaphore, okay, as I told you. So my dear friends, please note down this point also. Reader writer problem is another classical problem, of process synchronization, okay, process synchronization. So if two processes, that means reader and writer want to access the common database, that is known as critical section. Okay, you can consider database as a critical section. Okay, want to access the common database together, then together without any synchronization, without any synchronization, then various problems may occur. And what are these problems, my dear friends? As I told you, what are these problems, my dear friends? Just listen me carefully. First, need to listen me carefully. Then I will give you the time to note down. So here I have a reader process, and here I have a writer process. Okay, and both reader and writer both are using the same database. Okay, DB. Both are using the same database, my dear friends. Okay. So what are the problems, my dear friends? What is the first situation where problems can occur? First situation is what, my dear friend? First situation is what? Suppose when reader is accessing the database, when reader is reading the database, when reader is reading the database, when reader is reading the database, and at the same time, when writer want to write the database, when writer want to write the database, or writer want to some changes in the database, so my dear friend, this is a problem. This is a problem. Okay, this is a problem. This is the first problem. Okay, so when reader is reading the database, then writer cannot make the changes at the same time. Okay, writer cannot make the changes at the same time in the database. Okay, so this is a problem. Second problem is what, my dear friends? Suppose writer is writing the database, writer is changing the database. Okay, writer is doing some doing some change in the database, and at the same time writer arrives to read the database. Okay, so it is possible? No, this is a problem. This is also a problem, my dear friends. So due to some problem, due to these problems, there may be inconsistency, loss of data. Okay, so we need to use what? Synchronization, and we will provide the synchronization between reader and writer with the help of binary semaphore. Listen me carefully. So these are two problems. Okay, and there is a one problem also. There is a one problem also. When one writer is making any change or changing the database, and at the same time another writer also want to make the change, another writer process also came and want to change the same database, so it is not possible. This is also a problem. This is also a problem, my dear friends. Okay, so there is a fourth case. There is a fourth case. Suppose when one reader is reading the database, and then at the same time another reader came and it also also starts to read the database, then yes, it can then both the two reader process can access the database simultaneously. There is a no problem. This is not a problem. There is a no problem, my dear friends. There is a no problem. Okay, there is a no problem. So these are the problems, my dear friends. Due to these problems, there may be inconsistency, there may be loss of data, there may be race condition. Okay, there may be various problems. Okay, so here I am going to give you the solution. Here I am going to give the solution of reader writer problem with the help of binary semaphore. For this we need to take two different codes. One code for the what, my dear friends? Reader, and one code for the writer. When reader will come to access the database, then it will execute the reader code. Okay, and when writer want to making some change, when writer want to make some changes in the database, then writer need to execute the writer code. Okay, understand? And we will use what? Binary semaphore. We will use what, my dear friends? Binary semaphore. So please note it down first. Please note it down all points carefully. Okay, with understanding. I hope to understand clearly. These problems may be arise. This is not a problem. When one reader is reading the database, another reader, and multiple readers can read the database simultaneously. No problem at all. But these three are the problems. Okay, friends, I hope you noted down this one. Okay, so let's see the reader code and writer code, and how we can provide the solution with the binary semaphore. Okay, of reader writer problem. Okay, reader writer problem. So here we are using what? Mutex semaphore, and another semaphore is DB. Okay, and here we are using this RC variable. Here we are using this RC variable. So we are using what? Three things. We are using here what? Three things, my dear friends. We are using RC. RC means is what? Read count. RC means is what, my dear friends? Read count. A reader count. Reader count. RC means is what, my dear friends? A reader count. Okay, number of readers in the buffer. Number of readers. How many number of readers reading the database? Number of readers. Reader count means is what? number of readers. Number of readers. RC will give you what? Reader count, number of readers. Any number of readers can read the database or access the database simultaneously. There is no problem. Okay. So number of readers present in database. Okay. So RC will giving you this, and here we are using this mutex. One thing also we are using this mutex. Initial value need to is what we need to initialize this mutex with what? One. As we have discussed binary semaphore, we need to initialize with 1. Okay, so here we are using this binary semaphore mutex and is initializing with 1, and we are using another semaphore db, and it is also we need to initialize with 1. Okay, we need to initialize with 1, and in starting and initially when no reader and writer are present inside the database, so initially need to put this RC value equal to what? 0. Means we are considering no reader is present inside the database. Okay, RC value is equal to what, my dear friends? 0. RC value equal to what, my dear friends? 0. So I am going to consider the case first. How it will provide solution for the case first problem. So what is the case first, my dear friends? What is the case first? What is the case first? Suppose a reader comes, okay, and it want to access the database. Suppose reader comes and it want to access the database. So it will execute this entry code to access the database. It will execute this entry code, and when it will execute this entry code, then it will enter into the critical DB, means this is a critical section. Okay, and for the exit, it will execute this exit code. Okay, listen me carefully. Okay, so when first reader comes, so reader will execute this code. Okay, so reader will execute this code. Okay, so from here while true, this will always true. Down of mutex, reader will execute this entry code. Down of mutex need to down from 1 to 0. Okay, RC equal to RC plus 1. We will replace this RC reader counts, means one reader is going inside the database, tries to access the database. So RC equal to RC plus 1. So it will become from 0 to 1. Okay. If RC equal to 1, yes, here RC equal to 1, then down DB, then we need to down DB also. So it will become 1 to 0. Okay. Then up of mutex need to be up. Okay, 1. It will become from 0 to 1. Then this reader will enter into the critical section, mean reader is able to access the database. Okay, is able to access the database. So when reader is accessing the database, can any writer enter into the database, or can any writer also enter or also make the changes in the database or also access the database simultaneously? Let's check. Okay, suppose a writer comes here. So when writer want to make changes in the database, in the same database, then it will perform this code. My dear friends. Okay, so this is the entry code, this is the exit code. So it will perform this. Okay, it will perform this code. Okay, so writer will come here. So while true, down of DB, my dear friends. So DB is what? 0. When reader is reading the database, accessing the database, suppose writer came and also want to make changes in the database at the same time. Can it possible? No. Okay, so DB is what? 0. So we can perform what, my dear friends? Another unsuccessful operation? No, we cannot do it what? 0 to minus 1, because this is a binary semaphore. So this is not possible. So it cannot enter into the critical section. My dear friends. So writer is not able to enter into the critical section. Okay, writer is not able to enter into the critical section. So this is the case first. Okay, so it provides solution. So writer is not able when reader is reading, when reader is reading the database, okay, database, then writer is not able to access the database, to access the database, to access the database at same time, at same time. Okay, let's see when reader will come out, okay, from the database, then writer can go or not. Okay, so when reader want to exit, when reader want to leave the database, okay, then it will execute this code. So down of mutex, so it will down the mutex, okay, it will become from 1 to 0, okay, rc equal to rc minus 1, 1 minus 1, it will become 0. Okay, if rc equal to 0, then up of db, yes, rc equal to 0, then up of db, up of db will we will up this db from 0 to 1. Okay, up of db, up of mutex, we need to also up the mutex. Okay, so now up of mutex, okay, process data. Okay, then after executing this code, reader will come out from the database, from the database. Now if writer want to go, now when reader comes out from the database, now if writer want to go, okay, I am explaining, write down in your own language. When writer comes out from the database, okay, comes out from the database, okay, comes out from the database, if writer want to go, then writer can go, my dear friends, then writer can go. Okay, if r1 comes out, so only one by one they can go. If reader is there, then writer cannot able to write the database. Okay, this is the first case. So when R comes out, when reader comes out, then writer can enter into the database. Writer can make the changes in the database. Okay, so it can execute this code. Let's see. Let's see. Okay, let's see. When R comes out, okay, then what, my dear friends? Writer need to write this entry code. Okay, so while true down db, yes, we can perform down operation on db. Okay, yes, database, it can enter into the database. Now it can make the changes in the database. Now when r comes out, reader comes out, up of db, up of db, when it want to leave the database, then it will make what, up of db. If next time if reader want to go, then reader can go. This is the first situation. So on the alternatively basis they can go, but both reader and writer cannot enter into the database at the same time. This is a problem and this is a solution. Okay, this is a binary solution. I hope you understand clearly. Please note it down. Then I will explain second problem, then third, and fourth one is not a problem. Reader, any number of readers can access the database, can read the database simultaneously. This is not a problem. That is not a problem. Okay. So this is the case first. I hope you understand. When R comes out, then W can access database. Okay, you will understand when you will write like this. When R comes, then W can enter, can access DB. When R will execute this exit code, then W can enter into the database, make the changes into a database. So please note it down and note the points in your own language. You will understand clearly. I hope you are noted down this one. So now I am going to explain the case second. I will take each and every case, don't worry. Okay, so first I am going to, make all the things just like as initial. Okay, so here mutex is 1, db is 1. Okay, RC value is what? Need to put 0 initially. No reader inside the database. Okay, so this is the case first. Now I am going to take what? Case second. Okay, now I am going to take what? Case second. Case second. When case second, suppose writer comes first. Suppose writer, W means writer comes first. Okay, it will execute the writer code, my dear friends. Suppose writer comes first, means it will execute the writer code. It will execute the writer code, my dear friends. Okay, so writer code is what, my dear friends? This is the entry code. It will execute to access the database, to access the critical section. You can consider database just like as a critical section. It will execute this entry code, my dear friends. Okay, so down of db, it will perform down of the db. Yes, it will become 0. Okay, it will enter into the database, means it is able to access the database, means whatever changes it want to make, it can do. Okay, okay, and at the same time, when writer also comes, so it is able to access the database. And it is making the changes into the database, and it enters into the database means making the changes, whatever it want, making the changes into database, into db. Okay, and at the same time, when reader comes, and it also want to read the data, when writer is writing the data, then it is possible, no? So can reader enter? When writer is writing the data, making the changes in the database, can reader enter into the database? Reader is able to access the database. Let's check. Okay, so when reader will come, so reader will execute this code. This is the entry code and this is the exit code. Okay, so reader will execute this code first. Okay, so integer RC equal to what? 0. Yes, integer RC equal to 0. Semaphore mutex equal to 1. These are the conditions. Okay, so it will execute this code. Down of mutex. Yes, it is able to down the mutex. Mutex will become 1 to 0. Okay, down of mutex. RC equal to RC plus 1. Okay, yes, RC value will become what? 1, from 0 to 1. If RC equal to 1, yes, if RC equal to 1, yes, RC equal to 1, then down of db. So we can perform here down operation, because down db is also 0. So reader is not able to perform the down operation. db down operation means it is not able to enter into the critical section when any writer is present inside the critical section and it is making the changes into the database. Then reader cannot come into the database at the same time. Okay, so when first writer comes and it is making changes into the database, then reader cannot access the database at the same time when writer is present inside it. I hope you understand clearly. Okay, so now this way, this binary semaphore will provide the solution. When W comes out, when W want to come out from the database, means okay, comes out. Okay, like this, you need to note down the points. Okay, like this, or in your own language. I am giving you complete explanation. Okay, guys. So when W comes out, then it will execute this code, this exit code. Okay, this exit code. So up of db, so it will become what? Up of db. Okay, it will become what, my dear friends? Up of db. Okay, up of db. up of db, understand, up of db, okay. So up of db, now up of db, so reader cannot come when this comes out, when this comes out, my dear friends, when this comes out, okay, then this is the situation, this is the situation. Now reader can, when w comes out, then it will execute this code up of db. So db is what, 1, db is what, 1, my dear friends. So now reader can enter into the critical section. Yes, now reader can enter into the critical section. So it will execute this code, okay, it will execute this code. So here, this is the situation, it will execute this code, my dear friends, it will execute this code, okay. Integer rc equal, it will execute this code, okay, it will execute this code. So down of mutex, yes, 1 become 0, 1 become 0, rc equal to rc plus 1, okay, 1, okay. If rc equal to 1, yes, then down of db, yes, we can perform down of db operation, okay. Then need to make what, up of mutex, okay, we need to make this up of mutex 1. Now this reader can enter into the critical section when w comes out. Then now this reader, okay, reader can access database, then reader can access database. Both cannot present at the same time into the database, okay. So now this way, this binary semaphore will prevent, okay, or will provide the solution for the case second. Now the case third, please note it down, this case second. So I will explain here what case third. So I hope you noted down, guys, this. I am going to take the case third, okay. I am going to take what, my dear friends, case third. I am going to explain the case third, my dear friends. Initially, RC value is 0, mutex is 1, okay, and DB is 1, okay, DB is 1, okay, DB is 1. Case third is what? Writer. Case third is what? Writer. If any one writer is present inside the database, means it is making the changes in the database, then another writer cannot enter into the database at the same time, means another writer will also not able to make the changes at the same time in the database for the common database. So when this writer comes first, okay, when this writer presents, okay, when this writer comes first, okay, then writer will execute this code, my dear friends, writer will execute this code, okay. So down of db, there is a down of db is what, my dear friends, 0, it will become 0. First writer will enter into the database, okay. So this writer enters into the database, to make changes into database, and suppose another writer will come, so can it enter into the database, my dear friends? No, that writer cannot come enter into the database, means both the writers cannot present or cannot make the changes in the same database at the same time, okay. So this will also execute this entry code, my dear friend, so it will need to perform down of db. So down of db is what, 0, So we cannot perform what down operation on DB because this is a binary semaphore. Okay, this is a binary semaphore. Understand? So we cannot perform a down operation again on DB because DB is equal to what? 0. And binary semaphore will take only two values, 0 or 1. Okay, 0 or 1. So it is not able to enter into critical section. Not able to enter into critical section. Sorry, into database. Means you can consider here database is what just like a critical section. When this first comes out, means it will execute this exit code up of DB. It will make this up of DB is what 1. Then only another. Then this one can enter. Now when first writer comes out, from DB after executing exit code, then only this writer can go. Into DB, and whatever it want to do, it will do. Okay, whatever it want to do, it will do. Okay, this is the case 4. Okay, this is the case 4. Now we are going to see how many number of readers can access the database at the same time. Okay, so through this code we are going to see. This is not a problem, my dear friends. So please note it down this first, then we will see the case 4 here also. My dear friends. Now we are going to see the case 4. Okay, now we are going to see the case 4. Means multiple readers can present inside the database. Okay, this is not a problem. Let's see multiple readers can present or not. Okay, so suppose this reader comes, R1 reader comes, will execute this code. Okay, Okay, so it will execute this code, my dear friends. It will execute this code. Okay, so here it will become what? RC. It will become what? RC equal to RC plus 1. Okay, down of mutex need to down this mutex. It will become from 1 to 0. Okay, RC equal to RC plus 1. So this will become what, my dear friend? This will become is what? 1. This will become is what? 1. If RC equal to 1, then down of DB, make this down of DB here. Make this down of DB. Okay, make this down of DB. Up of mutex, make this up of mutex 1 here. Okay, make this up of mutex 1 here, my dear friends. Okay, so R1 enters into the critical section. Now again R2 want to read this database, then R2 can enter into the database, or R2 can access database or not, my dear friends. Let's check. Okay, so it will execute this down of mutex. It will make this mutex 1 to 0. Okay, and RC equal to what, my dear friends? RC equal to what? RC plus 1. RC equal to RC plus 1, my dear friends. RC equal to what? RC plus 1. Okay, so RC equal to what? RC plus 1. So here RC will become what? 2, my dear friends. RC will become what? 2, my dear friends. If RC equal to 1, then only down of DB. Otherwise else up of mutex. So it will become mutex equal to what? 1. Then R2 will also able to enter into the critical section. R2 can also read the database. Now R3 came, means many readers can read the database at the same time. This is not a problem. Okay, so now it will execute again down of mutex 1 to 0. Okay, RC equal to RC plus 1. It will become what? 3. If RC equal to 1, then only we need to perform down operation, otherwise need to perform up of mutex. So it will become from 0 to 1 again. Then R3 will also able to read the database at the same time. So many readers can present in the database at the same time. This is not a problem, but three are the problems. If there is a reader inside the database, means anyone is reading the database, then writer cannot perform the write operation on the database at the same time. When reader will come out, then writer will perform the database. Okay, then writer will make the changes in the database. Second case is what? If writer is present, means writer is making any changes on the database, then reader cannot read the database at the same time. How it prevent? By using the binary semaphore. Okay, we have discussed. And third is what? When writer is there, then another writer cannot also perform the changes on the database at the same time. Okay, two writers cannot perform the changes at the database at the same time. This is also a problem, and we have discussed how this problem prevent by the binary semaphore. Okay, so we have discussed each and everything. We have discussed what is reader writer problem, and we have also discussed the solution of reader writer problem with semaphore, binary semaphore. So please note it down this. Okay, please note it down, my dear friend, this one. So I hope you noted down this one, guys.